So, hello everyone, my name is Daniel, I work for Outreach, and I would like to talk about Protobuf internals, specifically about how the Protobuf messages are encoded into the actual data that you then have on the wire. So, what is this? Yeah. Okay, so it will be a lot about numbers today. So let's start with a few numbers about me. So I've spent more than 20 years programming software. The last 6 years in Golang. And when I was starting to learn Golang, I created a project called GDU, which is about analyzing disk usage. And it became quite popular later, so it is quite some stars on GitHub. And the last number from me, I work more than 4 years now in Outreach, and I'm still happy there. So if you consider changing job, maybe you can ask on our booth. Now I would like to ask a few questions about you as well. So please raise your hand if you have heard before about protocol buffers or Protobuf. Okay, almost everybody, that's great. And have you heard about protowire format? Okay, not everybody, that's great. So we'll have something to share. So let's dive into it. So quick intro. So Protobuf, we can simply say it's a mechanics for serializing structured data, similarly as what XML or JSON does, but it should be somehow faster and more space efficient. And how it works? We first need to define a schema in a proto files, and the basic entity of the schema is a message, and the message has fields. And every field has a type, name, and a number. So these three main parts. So yeah, you all know this. And then what is a protowire? So protowire is a format that defines how your messages will be actually encoded on the wire into the actual bytes. And this will be our focus for this talk. And you can imagine it as UTF-8. It's somehow similar to UTF-8, what it does for Unicode. So what is the flow? So first we define the schema. We have this proto file. Then we use the compiler, which will create for us a Golang struct. So here we have a Golang struct. We can populate it with some data. In this case, we have some integer, we have some string. And then we call a proto marshal. And this call actually does two steps. So first, it converts our concrete types like string and uint64 into something that we call wire types. And wire types are basically just two. Like there are more, but the main ones are two, and that is a number of variable lengths and something they call length delimited payload, or we can say just byte array. So we convert the concrete type into a number or byte array, and then we call protowire logic, and that will create for us the actual bytes that we can then send on the stream or save to some file. And it's important to note here that in this stream we don't have field names and we don't have the concrete types. It's very important to remember and to know this. And that's why on the other side, on the receiver side, we need to have this schema to be able to fully unmarshal the message. Because of that, because we don't have the names, we don't have the types, we can save some space on the wire. So, so what happens on the receiver side, we call proto unmercial, and what it does is basically the opposite. So first it uses the proto-wire logic from the stream to get the field number and the encoded payload of the values, and then using the field number, it checks what is the actual schema and gets the concrete type for each of these values, and then it's able to convert back the payload into the concrete types. So we again have here the integer uint64 and we have the string. Yeah. So why does this matter at all? Why should we care? So one reason could be if something stops working. For example, we get some message, we are not able to unmercial it, we don't know why. What's happening? So in that case, we can either decode it manually or use some tooling, I will show it later, which will tell us what actually is on the wire, if there are the correct field numbers, if there is the payload, and so on. So that's one reason. The other reason is that if we know how exactly the proto-wire encodes your data, you will be able to better pick which types to use. One example, if we have a small number, for example, number 1 or something like that, it will be encoded if we use Protobuf type int64. It will be encoded into 1 byte only. Not 8 bytes as you would expect on 64-bit machine, but into 1 byte. But if you use the same type and you will try to send -1, so negative number, it will use 10 bytes. So that's good to know. So for negative numbers, you should use different type, which is signed integer, which encodes in different way, but we most likely won't have time to go into that right now. And last reason, quite specific one, but in some cases, in some specific cases, you can get some more performance if you don't unmercial the messages fully, like using the normal tooling, but if you just use the proto-wire and get just the field numbers and the raw payloads. In some cases, it could be enough for you to get just these, and you can save some memory and CPU. So how does the data look like, and how can we decode it? So in essence, the data are a sequence of records. So we have here 3 records. Important is that the order doesn't matter. So we can get this one first, or this one, or this one. It's totally like equivalent. And every record has 2 parts. The first one is a tag, and the second one is the actual payload. And in the tag, there is encoded a field number and also the wire type. And I will show how exactly it's encoded. For now, it's just good to know that it's in the tag. And the tag can be 1 byte or multiple bytes. We will see later. So, and again, you see we don't have any field names here on the concrete types being transferred over the wire. Okay. So now, how to decode the tag? It's actually quite simple. To even simplify it more, to be understandable, let's assume that the tag for now is just 1 byte, 1 single byte. And it's encoded in a way that the last 3 bits of the tag are, there is the wire type. And the rest is the field number. So if we have use just 1 byte, we can have just a few field numbers. I will show later how it's in real. So if we get tag, which is the number 34, what we need to do is to byte shift it by three bits to the right, and then we get the field number 4. To get the wire type, we need to do a bit end with number 7. So yeah, with number 7, and we get the wire type 2, which is len, length delimited payload. Yeah. So what are the main wire types? It's the VarInt, or variable length integer. It's a fixed int, and it's the length delimited payload. These are the main 3. There are a little bit more. Some are deprecated, but these are the main ones that are being used on the protowire layer. So as I said it's 1 byte. Actually, it's not 1 byte. It's this guy. It's the VarInt, which means we can have a lot of field numbers, right? We are not limited. So if it's a VarInt, how will we decode that? It's again quite simple, similar to how UTF-8, for example, does it. So VarInt, it's a way how to encode unsigned 64-bit numbers into 1 to 10 bytes. It can be 1 to 10 bytes. And every byte, its first bit, or the most significant bit, it's a continuation bit mark or flag. So every byte says if it's the last byte of the VarInt, or if one more will follow. So to get the full VarInt, you need to go byte by byte and check always the first bit or most significant bit, and see if you need to read more or not. So then you have the rest is the payload of the number, and how to decode it. Let's see the example. So we have, for example, number 150. It's encoded as 2 bytes. Here we see the binary form of the 2 bytes. So first we check the most significant bit. This one is 0, so we don't need to read further. We remove this first bit. Then we have the 2 bytes, but we have it in a little endian order as it comes over the wire. So to interpret it correctly, we need to switch the order into big endian, and then we can just concatenate the 2 bytes, and we just interpret it as a normal number, and thus we get the number 150. Good. So these are VarInts, one of the most important parts there. The other wire type that is important is this length delimited payload. And how it works is that we again have the tag, but after the tag there is a length of the payload encoded as VarInt again. And thus, if we read the tag and then we read this length variant, we know how many bytes we need to read further to get the payload. So, and this len records can be used for multiple concrete types. So for strings, bytes, submessages, or packed repeated messages, packed repeated fields. So one example, we have a string. We can see it's 4 bytes. First byte is tag, which encodes field number 2 and wire type 2 as well, so it's a length. The next byte is the length, and we see number 2, so it's easy, it's 2 bytes. 2 bytes follow, and here we have 2 bytes, and if we interpret them as a string, we get the string go. So quite simple. Okay, so now let's see some code. What's the time? Yeah, time is quite good. So here I have some simple message with just one field with type unsigned integer 64, and I will first call the protoc to get the struct that I can use. So protoc finished. So I now have this pb.go. You probably know it, and here I have the generated struct that I can now use. So I have some simple example. I populate the struct with one value. I call the Marshall, and I get the resulting bytes. So now let's try to decode the tag of this from this data. So what we need to do is to get a wire type. It's quite hard to write with one hand, but I will try maybe I can try this one, but I'm not sure. Yeah. Yeah. Okay. Doesn't matter. Yeah. So to get the wire type, we simply get the first byte, and we do the bit end with the number 7. And to get the field num, I can just yeah. I think it's okay. I will somehow finish. Yeah. To get the field num, we just byte shift by 3. As I said, in this case, I am pretending it's a single byte. So if I did it correctly, I would need to check that the first byte isn't actually the continuation byte. So something like this, and I would, for example, panic. Yeah, and yeah, to read it correctly, I would need more logic. So yeah, that's how I get just the field number and wire type from the first byte. So let's see if it works. Yeah, panic. Okay, something wrong. Yeah. Like this. Yeah, again panic. Yeah, okay. Let's skip this check for now. Yeah, so we see field number is 1 and wire type is 0. I have some mistake in my head right now. So that was the first byte with the tag. Let's now see some more complete example what we can do. So I have a little bit longer stream of data, and let's try to decode it. So I defined function consume tag that does basically what I have shown before. So this byte shift and bit end, and then based on the wire type, I have some handling there. If I read VarInt, again simplify it. I don't care about if it's. I pretend it's just 1 byte, so I just print the byte as integer. And if it's the length delimited wire type, then I need to first read the length, stored in the next byte, and then I can print the whole payload. So let's see. And so what we get, we got with field number 1, we got integer 5. With field number 2, we got the length delimited, which is string go, and with field number 3, we have repeated integer, which we cannot translate to string, of course. Yeah. So good. So this works. It's like simple, but it works. But of course, in most cases, we wouldn't. Yeah, we can validate if we really did what it's. We can validate that basically what we decoded is really what is there. So I created the message what I get from the stream. I will serialize it, and I will compare if the stuff that I read and the stuff that I think it's there, if it's really the case. Yeah. So equals true. So confirmed. And in normal cases, you wouldn't write this logic by your own. You would use at least the Protowire package, which is in Protobuf, and that's the package that's actually used by Protobuf itself to encode and decode the data. So you can use it yourself, this package, and you can yourself decode the text. You can decode the VarInts. You can decode the data. There is one caveat. This consume field value wouldn't give you the actual payload. It will return just the length of the payload, and you need to do it yourself. So yeah, you need some again some switch on the types and so on. So yeah, so this you can use. And then there is another utility that you can use, and that it's called Protoscope. Have you heard about Protoscope? No? Nice, okay. So Protoscope is a utility that allows you to basically see the data on the Protowire level. So if I copy the bytes that I was working on, and I will just send it to this utility Protoscope, it will tell me something. Oh, I will copy it. It will tell me something. Okay, again. Yeah, do you see it? Okay. Yeah, so it tells me that there is, it doesn't know the field names, so, but it can tell you there is field number 1, 2, 3. The first one is VarInt 5. The second one has a payload which is length delimited something, and it can be interpreted as a string. And the last one is again something length delimited, but it cannot be interpreted as a string. It's some bytes. It doesn't know more because it doesn't have the schema. And so this protoscope you can use if you get some data and you don't know what's somehow wrong. You can see if there is, for example, some nested message, some sub-message inside it. And yeah, so some basic view on the data that you are getting. Okay, so to recap, so the protowire format is there is a message. The message is a sequence of records. Every record has two parts, which is a tag and payload. The tag is a VarInt when the last 3 bits is a var type and the rest is a field number, and the var type is most likely a VarInt or some fixed integer with 4 bytes or 8 bytes, as in this example, or it's length delimited payload. And one recommendation, as I mentioned before, if you have negative numbers, don't use the normal int64. Use signed int64 or signed int32, because this one uses zigzag encoding, so number -1 will be encoded into 1 byte instead of 10 bytes. Okay. So that's all from me, but we have a small challenge for you related to this topic. So if you want to get some gift from Outreach, please go to this web page or scan this QR code. There is a simple challenge with Protobuf encoding, and if you solve it, we will give you something. And if you want some more reading on this topic, there are some links, and the slides for this talk are available on the last one, and there are the examples that I have used as well. So so you can check that. So thank you for your attention. Do you have some questions?